session 2012. So we'll begin with the exercise, electromagnetic conduction. A coil of horizontal axis is made up of n equal 500 circular turns, where the surface is 10 centimeters square. So it'll become 10 times 10 to the power minus 4 meters square. It's directed and direct, and n is directed as indicated in the figure. The coil rotates at a constant angular velocity. So here we must pay attention to this part. When I say constant angular velocity, this means I'm using a uniform rotational motion, which means that theta double prime is equal to 0, theta prime is equal to constant, and it's called omega here, and theta is equal to theta prime t plus theta 0. The same as a equal to 0, v equal to constant by antiderivative, and x equal vt plus x0. Now here theta prime, it's called omega, so it becomes omega t plus theta 0. This is theta in terms of time. Now it's all placed in a constant and uniform magnetic field B, where the terminals A and C are connected to the input of Y and M of the oscilloscope. So the question in the part 1, you have theta, let theta be the angle between N and B. Knowing that theta equals to 0 at t equal to 0, show that theta equal omega t. So as we said, in a uniform rotational motion, I have theta equal omega t plus theta 0. But at t equals to 0, it's given that theta equals to 0, which means theta 0, theta initial is equal to 0. This means that theta equal omega t, then it's verified. 2, deduce that the expression of the magnetic flux is given by. We know that the flux is NBS cosine theta, and all we do here, we substitute theta. So it becomes NBS cosine omega t. Part 3, justify qualitatively only the expression of the existence of an induced electromotive force. So in order to have an induced electromotive force, I must have the existence of the electromagnetic conduction phenomenon. This means I must have one variable. Here, the variable is theta, so I can say that theta is variable, since it depends on the time, which means that phi is variable. And if phi is variable, then we have electromagnetic induction phenomenon exists, which means that we have electromotive force, induced electromotive force that exists. So this is the explanation. Now determine in terms of NBS omega and T the expression of the induced electromotive force. So here, according to Faraday law, we know that E equal minus d phi over dt, and we already said that phi equal NBS cosine omega t. So by doing the derivative, these are constants. So I'll have NBS, and we have here the minus. So the derivative of the cosine, it's minus sign. So it'll be plus here, and omega sine omega t. Then this will be the electromotive force. B, the coil does not carry current. Why? If we notice here in the figure that it's an open circuit, so it's an open circuit, then we don't have current. So since we have open circuit. Part C, deduce the expression of the voltage UAC, knowing that the coil is oriented positively from A to C. So UAC, it's equals to RI minus E. It's an open circuit where I have here RI is 0, since the current is 0. So it'll be minus E, which means it's minus NBS omega sine omega t. Now part 5, the waveform here in the figure 2 represents UAC as function of time. Using the waveform, determine the angular velocity. So we know that omega equal 2 pi times the frequency, but the frequency is 1 over t. And كيف نطلع t? So نطلع here على graph t equal sh times x, which equal 10 millisecond times, we have 4 division. So this is 4 division. So it's equal to 40 millisecond. This means 40 times 10 to the power minus 3 seconds. And by substitution here, so we'll get 157 radian per second. Now I want to find the maximum value of the voltage UAC. So UAC maximum, by using the graph also, is equal to SV times Y, which is 1 time, so I have here the maximum is 3, then is 3 volts. C, the value of B of the magnetic field. In order to find now B, لازم ننتبه لتتابع الأسئلة. Okay, so what do we have? Now we have, the question was find UAC maximum, but I know that UAC is an expression of the sign, it's a sinusoidal equation. So this part here is the maximum, which means that UAC maximum is equal to NBS omega. So 3 equal, it's 500 turns. We must find B. We have the surface is equal to 10 times 10 power minus 4, and we have omega 157. So by dividing, we'll get B equal to 3 over all this, so it's 500 times 157, and the answer will become 0.038 Tesla.